Hello everybody, this is Mr. Zarzak. In this tutorial, I will cover two important rounding rules for when you're performing calculations with data or measurements that has been collected and reported with a specific number of significant figures. These rules are important for communicating the level of uncertainty in a solution to a calculation that uses data collected in the lab. So the good news here is that when you're performing any calculations with lab data, nothing changes in terms of how you do your calculations. Significant figures only get considered when reporting final answers, so think of the rules we develop in this tutorial just as an extra step added on to the end of normal calculations. And I can't stress this enough. Rounding and considering significant figure rules should only occur when you're reporting your final answer. When performing calculations with lab data, the number of digits we're ultimately going to round to depends upon both the number of digits we have available to us to begin with and the kind of calculation that we perform. I would suggest you pause the video along the way to take a few notes for your own reference, or you could just come back to this tutorial throughout the year and listen to me again and again and again. It's a tough choice, I know. Okay, here we go. Our first rule covers what to do with significant figures when performing operations involving multiplication and division of data. And the rule goes like this. All you need to do is determine which piece of data that you're either multiplying or dividing has the least number of significant figures, and that's going to tell you how many significant figures to round to at the very end when reporting your answer. Okay, so let's jump right in and do an example. In this example, I'm just going to multiply these two numbers. Alright, before I do my multiplication, I'm going to determine how many sig figs are in each of the two values. So the first number here, 1.23, actually has 1, 2, 3 sig figs. And the second number here, 4, 5, 6, 7.89, has 1, 2, 3, 4, 5, 6 significant figures. The 1.23 has less, so after I finish my calculation, I'm going to round my answer to 3 significant figures. If I use my calculator to do this multiplication, my calculator is going to report out this value, which is pretty darn big here, but I only need to worry about reporting this value to 3 significant figures. Okay, so if I go and look at the number, I got the 5, the 6, and then here the 1 would be the least significant figure, but I have to round, so the next digit happens to be the 8 there, so I would take and round this value to 5, 6, round up to 2, and put a 0 in the ones place. Since we are in a science class, it is of course important to know how to express this value in scientific notation. The number 5,620 could also be written as 5.62 times 10 to the third. Okay, so here's an example for you to try. I'd really suggest that you pause the video and give this a shot before you listen to me explain the solution. So pause now and good luck. So first I'm going to determine the number of significant figures in the two values I'm going to multiply together. So for this top number here, I've got, let's see here, 1, 2, 3, 4, 5 different significant figures. And for the number underneath, looks like I have 1, 2 significant figures. Alright, so it looks like 2 is less than 5. Alright, so I'm just going to kind of keep that in the back of my brain. Go ahead and perform my calculation, and then I will worry about which value to choose as my answer. If I put the value 6.5315 into my calculator and I multiply it by 4.5, my calculator is going to return 29.39175. If I remember from before, I'm going to round my final answer to 2 significant figures. So I consider the 2 and the 9, and I look past the decimal to see here, 3 is closer to 0 than the 10, so I'm just going to take and round my final answer to 2 significant figures, which is 29. Again here, the 4.5 that's involved in the multiplication has the fewer number of significant figures, so that's going to be the number that limits our precision, which is why we round our final answer to 2 significant figures. Okay, our second calculation rule tells us what to do when we're performing either addition or subtraction. And for these kind of operations, we're only interested in the number of significant figures that occur to the right of the decimal points. So for this example here, we're going to add two numbers, but we're only going to look at the number of significant figures after the decimal point when determining how to round after we perform our calculation. So this first number, 1.234, I'm just going to count the number of sig figs after the decimal here, 2, 3, 4, so that's 1, 2, 3 sig figs. Alright, whereas if I look at the second number, this 567.89, it's only the 8 and the 9 after the decimal point that I need to keep track of for significant figures, so there's 2 for that. Now when I'm doing addition or subtraction, I actually like to write out my numbers like this. One, because I'm old school and I like to do these calculations by hand, but two, it really makes it obvious which of the two pieces of data are more precise. You can see here that there's more digits after the decimal with the 1.234 and less with the 0.89 here after the decimal, which is why this 567.89 is the least precise value for our data. When I do the straight-up addition, I get 569.124, and then for our rules with calculations using significant figures, we do our rounding at the end. Because the 567.89 was the least precise measurement with 2 digits after the decimal point, when I report my final answer, I'm going to round to 2 digits after the decimal point. The 4 value here is closer to 0 than 10, so I can just report my final answer as 569.12. So again, here's an example for you to try. I would suggest that you pause the video and give this a shot before listening to my explanation of the solution. Good luck. Okay, so let's finish this problem. Because I'm doing an addition, I'm only interested in the number of digits that occur to the right of the decimal place. So if I look at the top number, the 123.15, I'm only interested in the 1 and the 5 in terms of significant figures. So that has 2. And for the second number that'll be added to the 123.15, I've got 45.123, so all I got to worry about is counting 1 to the 3 digits to the right of the decimal. Alright, in which case the 123.15 is the least precise measurement, and so that's how many digits I'm going to round to after I perform my calculation after the decimal point. Okay, so when I perform this calculation, the solution here, either from adding this up by hand or in my calculator, is 168.273. And because I've already determined that the 123.15 with 2 digits after the decimal is the limit to my precision, I know I just need to take this number and round it to the second decimal place. And once again, the 3 is closer to 0 than it is to 10, so I just leave my final answer written as 168.27, which makes my answer choice A. If you have any further questions about addition, subtraction, multiplication, or division rules for significant figures, please see your physics instructor. And congratulations, you have survived this tutorial. See you in class.